All right, we already established the fact that when we get to a particular number in modular arithmetic, we always wrap up our counting. So a good example is the wall clock. So if I told you that the time was 15 o'clock, now on the 24 hours clock, 15 o'clock makes sense, but our time, our wall clock is a 12-hour clock. So what do? You already know by, that you already know that 15 o'clock means 3 o'clock. And how do you get that? Because you wrapped up at 12. So after counting from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, you wrapped up, and then you got to 12, you wrapped up and started from here, 13, 14, 15. So it means that 15:00 p.m. is the same as what? 3 o'clock p.m. Alright, so the clock, the wall clock actually is a very good example of modular arithmetic. Now, this is said to be modulo 12. Modulo 12. Why? Because at 12, we always wrap up our counting. So the only difference is that now when we'll be dealing with some questions on modular arithmetic here now, we are going to be using this wall clock technique because it's a very simple technique. Now, one thing you must know is that whenever you are doing an addition, whenever you are doing addition, you count in clockwise direction. If you are doing subtraction, now this is clockwise direction. If you are doing subtraction, this is addition. If you are doing subtraction, you count in anti-clockwise direction. So that's subtraction operation. Now notice that I put this sign in circle. Now the reason why we put signs in circle in modular arithmetic is to show that it is different from the ordinary arithmetic, the normal arithmetic. So putting the sign in circle shows us that this is modular arithmetic. Alright, so we said that, now if I told you what is 21:30 p.m. So you are going to count this way. When you get up to 12, 1 to 3 to 12, and then you continue 13, 14, 15, 16, 17, 18, 19, 20, 21. So that is 9:30 p.m. Alright, so you see that although you were told 21:30, 21 is greater than 12. So we wrap up at 12 and start to count from 1 again, and we get 9:30 p.m. This is going to be a very useful piece when we want to do modular operations in modular arithmetic. Alright, the only difference is that when we'll be drawing our clock for it's called number cycle. We'll be using the number cycle. When we want to draw our number cycle, our modulus will not be included. Our modulus will not be included. We'll turn this to 0 because when a number is in a particular modulus, the number must not be up to that modulus or more than that modulus. Alright, so that's why we always wrap up at the modulus. Okay, so for example, if we are told to do this addition operation, so we are starting with the addition. If we are told to do this addition operation, say for example, 2 plus 3 in mod 5, for example, in mod 5. Alright, now there are two ways you do this math, but I'm going to show you the easiest method first. Now what you do is this. You have 2 plus 3. What does that give you? 5. And you know that the number in a modulo, the number must not be up to that modulo. So this is already up to the modulo. So what you simply do is very simple. You divide by that modulo. If you divide by the modulo, here you are going to get 1. And what is the remainder? 0 is the remainder. So the answer is going to be 0 mod 5. Make sure that you repeat the mod to show us that you are solving a modular arithmetic. So because of course 2 plus 3 is 5, but in modulo 5 it is 0. Alright? Now, another way to do this is this. You can draw your number cycle. So we said we'll be using the number cycle technique. Now, on the number cycle, what we are going to have is 0. I told you that the highest number is going to be written as 0, then that's the modulo. And 1, 2, 3, and 4. So with this, we can now do 2 plus 3. So we stay at 2 and count plus 3. 1, 2, 3. You see how easy that is? Now, we are going in the clockwise direction because it is an addition operation. So we'll go in the clockwise direction from 2, 1, 2, 3, and that gives us 0. Alright, another example is if I ask to do 15 plus 8, for example, in say modulo 4, or let's still use modulo 5. So there you have the number cycle here, mod 5. So notice the number cycle for modulo 4 will be different from the one of modulo 5. As modulo 4 is going to be 0, 1, 2, and 3 without the 4. That's modulo 4. Alright, so if we ask to do this addition, 15 plus 8. Now, it will be, of course, you can still use the number cycle, but it will be foolish to do that because it's going to take your time. We are going to use it, and you will see how time taking it is. But the easiest method is the one we used here. By doing this plus this, is going to give you 23 actually. But you now divide by 5. We are looking for the remainder. It's going to give you 4 remainder 3. And so the remainder is our answer. So the answer is going to be 3 modulo 5, and that is our answer. So that is additive operation in modular arithmetic. But if you want to do 15 using the number cycle, it's very simple still. Now note that both 15 and 8 are not in our number cycle. So what you have to do is create 15. How do you create that? You have to count to 15. You start 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. Oh, sorry. We are going to 15, I'm sorry. So we count it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Notice we stopped at 15. I'm going to tell you why. So 15 is here. We are adding 8. 15 plus 8 now will be 1, 2, that's 15 plus 8. So I'm going to count 8. I'm going to count 8. I'm going to say 15 plus 8. That is 15, 16, 17, 18, 19. That's 4. 19, 20, 21, 22, 23. So notice that is confusing. So it's actually confusing. So it's easier to do the division method. But another way to also count is, you know that if you see that any of the number is divisible by 5, just go there and count and put it as 0. So if it's divisible by the modulo, it's going to give you 0. Alright, so then you add 8. 8 is 4. You go 1, 2, 3, 4, 5, 6, 7, 8. So if you are at 5, you just count your 8. You are at that modulo, which is 0. Simply count 8. 1, 2, 3, 4, 5, 6, 7, 8. And you get your answer. Alright, that's basically it for addition operation. So we always wrap up at the modulo. That is the take home here. Alright. The next is the subtraction operation. If you're asked to do, I'm going to basically be using this modulo 5 in my example because I have drawn the number cycle here. So if I ask you to do the following, one example, I say find 5 minus 2 in mod 5 still. So 5 minus 2 is what? Is 3 mod 5. Notice that nothing changed here. Nothing has changed. Why? Because 5 minus 2 is still 3. So how do you do that on the number cycle? You know that this number 5 is divisible by 5, so you can start from here. So when you subtract 2, you go from here, you go 1, 2. So my answer is 3. And that is how to do it. Alright. Now, number 2 example. What if we have a bigger number, like 10 minus 4, for example, mod 5, the same mod 5. So we want to wrap up at 5, and we're doing 10 minus 5. So we'll go 10. Now, how do we get 10? No, let's use a number that is not divisible. So because 10 is still divisible by 5, we go from here, because if it's divisible by 5, it always give us 0. So we'll go from here, we just go backwards in the anti-clockwise direction now. So we're going to have minus 4. 1, 2, 3, 4. So the answer is going to be 1. When we do 10 minus 4. The other way to do this, using the division method, is this. Ordinarily, 10 minus 4, that's mod 4. Okay, let's do that. Ordinarily, 10 minus 4 will give you 6. But you now divide this by 5. This 6 by 5 is going to give you 1 remainder 1. So that remainder is 1. So that is going to be our answer. 1 mod 5. So that is the other way to do it using the division method. Alright. What if we are now to do this? 4 now, in this case, minus 9, for example. So notice that when in the same one, 5. Notice that the number we are going to be subtracting from 4 is greater than 4. So how do we do that? It is very simple. All you have to do is this. You have 4 here. Now, if 4 can be found in the number circle, then very good for you. All you have to do is count anti-clockwise in 9 rounds, like that, from 4. So you say 1, 2, 3, 4, 5, 6, 7, 8, 9. So and that gives us 0. So we count again from 4. We have to subtract 9. So let's subtract now 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we stop at 0. That will be 0 mod 5. Alright. Now the other way to do this is this. Ordinarily, if we had done this, subtracted 9 from 4, we would get minus 5. So, and of course, minus 5, if you divide, now what you have to do is simply now since this one is divisible by 5, you can simply go and pick 0 as your answer, because every number that is divisible by the modulus will give you a 0. Alright. But if it were not divisible by the number, because it's a negative, you simply add the modulo. It's going to give you 0 here. But if it were, for example, if it were 5 minus, if it were like 8 minus 16. So here, you know it's going to give you minus 8. So simply add the modulo. If you add the modulo, you get minus 3. So there is no minus 3 in the number circle. All your answer must lie within this circle. So you add another 5. When you add another 5, you get what? 2. And that's going to be 2 mod 5 as our answer. But the other thing you could also do with this is, well, that is going to take your time anyways. You can't round again, around. That's going to take your time. Alright, so that's basically for addition and subtraction in modular arithmetic. In the next video, we are going to be doing multiplication and division. Do want to subscribe to the channel and click the bell notification to get updated whenever we drop a new video. Thank you very much. God bless you.